Hey everybody, Mr. Gajewski here, and today we're going to be learning about factoring with generic rectangles. So, 8.1.2, is there a shortcut factoring with generic rectangles? Since mathematics is often described as the study of patterns, it is not surprising that generic rectangles have many patterns. You saw one important pattern in lesson 8.1.1, Casey's pattern from problem 8-4. Today, you will continue to use patterns while you develop a method to factor trinomial expressions. So we're going to look at 8-13 for starters. Examine the generic rectangle shown at the right. Review what you learned in lesson 8.1.1 by writing the area of the rectangle at right as a sum and as a product. So I'll switch over to the document camera here first. So we're going to write this as a sum, 10x squared minus 35x minus 4x plus 14. You can go ahead and combine like terms. We get negative 39x plus 14. So there is my sum. Now as a product. So I'm going to factor each row and each column. So the greatest common factor of 35 and 14, I'm going to have 7. It's bordering a negative term, so we're going to make that a negative 7. All right, 10x squared and negative 4x, so I can factor out a 2 and an x. 10x squared and negative 35x, I can factor out a 5 and an x. Negative 4 and 14, I can factor out a negative 2. So to write this as a product, I have 2x minus 7 and 5x minus 2. All right. Does this generic rectangle fit Casey's pattern for diagonals? Demonstrate that the product of each diagonal is equal. So the product of each diagonal, so 10x squared times 14, I get 140x squared. Negative 35x times negative 4x, and we get 140x squared. So that does work with the pattern we talked about in the previous lesson. We're going to jump ahead here down to 8-15. Factoring with a generic rectangle is especially convenient when algebra tiles are not available or when the number of necessary tiles becomes too large to manage. Using a diamond problem helps avoid guessing and checking, which can at times be challenging. Use the process from problem 8-14, we'll talk about that, to factor 6x squared plus 17x plus 12. The questions below will guide your process. So, when given a trinomial such as 6x squared plus 17x plus 12, what two parts of a generic rectangle can you quickly complete? So I'm working with 6x squared plus 17x plus 12. I'll flip back to the document camera. All right. So here is the trinomial I'm working with. This is the trinomial I want to factor. So I want to make a generic rectangle. Well, what two parts can I always fill in right away? Well, I can take, if I look back up here, the first term and the last term, I can put those diagonal from each other. So in this case, I can always take the 6x squared and the 12. All right, the next part, let's flip back to our book. How can you set up a diamond problem to help factor a trinomial such as 6x squared plus 17x plus 12? What goes on top? What goes on the bottom? So if I think back to my diamond problems, all right, what two terms, when multiplied together, give me a product on top. And when I add them together, it gives me this right here. So if I take a look, what does that have to do with trinomials and factoring? Well, when I multiply these two, I know it's the same as multiplying these two boxes. All right. And the bottom, the sum, is these two boxes put together. So over here on this bottom problem, I'm going to multiply 6x squared times 12. That's going to give me 72x squared. This is my product. So whatever I put in these two boxes has to have a product of 72x squared. All right. On the bottom, I know that the sum of whatever's in these two boxes must be equal to this middle term here, so 17x. So I'm thinking to myself, classic diamond problem here. What two values multiplied together gives me 72x squared? When I add them together, I get 17x. So I can make a list of the factors. So 1 plus 72, well, that gives me 73. 2 plus 36, it's going to give me 38. Let's see here, how about 6 plus 12? That's going to give me 18. And what about 8 and 9? Well, that's 17. So 8 times 9, I get 72. 8 plus 9, I do get 17. So I'm going to have an 8x here and a 9x here. Now the order does not matter. I can flip these two around. So I can take this 8x and I can take this 9x and I can substitute them into my generic rectangle. Now I'm ready to factor. So 9x and 12, I can factor out a 3. 6x squared and 8x, I can factor out a 2x. 9x and 6x squared, I can take out a 3x. 12 and 8x, I can factor out a 4. So if I wanted to take 6x squared plus 17x plus 12 and write that as a product, my product would look like 2x plus 3 times 3x plus 4. Now I think this is my final answer, but just to be safe, we can do a check. So to do a check, we're going to multiply all this out, and it should equal this. So 2x times 3x, I get 6x squared. 2x times 4, I get 8x. 3 times 3x, I get 9x. And 3 times 4, I get 12. Combine my like terms. 6x squared plus 17x plus 12. So I got my original trinomial. So this right here is the correct factorization of my starting trinomial. That'll be it for now. I will do more examples for 8-16 in another video. Thanks for watching. Don't forget to like and subscribe. See you next time.